Computer. Computer, can you hear me?
Yes, I can hear you.
Yes! When I was a kid, this is what the future looked like. It wasn't just a world of computers. It was a world of computer creatures. These guys had personality. They had a soul.
Please, call me Johnny Five.
They were gonna be our friends, our co-workers, our enemies, even our pets.
That was the doctor.
This is what we thought technology would be like someday. And the future is finally here. Many of us already have a device sitting on our kitchen counter that talks to us, that answers our questions, that helps us get through our day. And what does this amazing machine look like? It looks like this. Don't get me wrong, Alexa is great. Our family uses it every day. But where is its personality? I don't need another computer in my house. We've got loads of those already. I want a device that interacts with me. I want a machine that feels like a character in the story of our lives. So today we're gonna try to solve this problem. Basically, we're gonna hack into one of the world's most popular virtual assistants, add some animatronics, add a screen from an old television, and see if we can make this machine feel a bit more alive. Let's get started. My wife has told me I can't buy anything here anymore, but I told her that we were building a robot and we need parts, so we better make this count. So here it is, one of the last generations of black and white CRT televisions ever produced. We've got it all disassembled and ready for the next chapter of its life. The concept here is that we're going to use this television to help our creatures speak. Because when users can see a voice being produced, when they can see a mouth moving, they're going to be more inclined to believe that they're interacting with a creature that is self-aware.
Yes, you see, frogs don't have ears, you see.
A creature that has feelings. Our goal is to inspire people to forget that they are talking to a computer. So let me show you what we got going on here. This is a pretty standard board for a small TV. We've got our flyback transformer here that provides high voltage up to the tube. This transistor is on a big old heat sink and is most likely our horizontal output transistor. And right over here, we've got 4 lines coming out of the board that control the horizontal and vertical deflection on the screen. And these are what we're most interested in. To make this display work for us, we're going to basically hijack the horizontal signal that's being sent to the tube and replace it with our own audio signal. To do this, we're going to desolder these 2 lines, attach them to an audio amplifier, and then connect the amp to our source. And if we've done this right, we should be able to see our audio come up on the screen.
These are his eyes. These his ears tuned in all directions to receive the slightest sound.
For the eye mechanism, I'm using a design developed by Will Cogley over at Nilheim Mechatronics. The beauty of Will's design is that it can be built quickly and cheaply with basically just an Arduino, a handful of servos, and a 3D printer. He's got all the files available for download on his Instructable, and he's also got a really cool YouTube channel for animatronics. I'll leave some links down below if you want to give this a shot. So here we have it, guys, our eye mechanism up and running. The servos, as you can hear, are still pretty jittery. I think that's because I don't have a power supply powerful enough for this yet. Actually, the power supply itself is plenty powerful for it, but I have to run it through this buck converter to knock it down to 5 volts, and this is limited to 3 amps. And I think for 6 servos, I think that's maybe not quite enough. I'm hoping that's the problem. So tomorrow I'll try to source a better power supply, and hopefully that will be a thing of the past. I'm controlling the mechanism right now with this joystick. This is just for testing purposes. The eyes will actually be controlled by this little board. This is a person sensor made by a company called Useful Sensors out of California. You can get this on the SparkFun website. I'll leave a link down below. This is a self-contained face tracking camera unit. I mean, if you were really ambitious and had lots of free time, you could of course program your own face tracking algorithm and pair that with a Arduino compatible camera. But not only do I not have that much spare time, my programming skills are just not up to that task. What this lets us do is that it lets our creature maintain eye contact with the user, even if the user is moving around. This means that she will not just be reacting when we talk to her, like Alexa does, but actually seeking out interaction. Watching you while you make dinner, for example, but in a friendly, curious way, like a child who wants to learn from you. I think this is going to be really cool. I want to take a moment and look at the Amazon Echo device itself, because I think I see a problem here. And the problem is this. Alexa is designed so that when she hears the wake word, she knows to then listen for a question or a command. Computer, what is your favorite robot?
My favorite is BB-8. I really like how he rolls.
The problem for us is that I don't want to have to tell our creature to wake up and then give her a command. I want her eyes to respond the moment I say her name, just like any creature would. But I can't find a way to program Alexa so that she will send a signal as soon as she hears the wake word. She's designed so that you have to say the wake word and then tell her what you want. But I think I might have found a solution. Let me show you what I mean. So this is our Alexa all disassembled. This is our main chassis and speaker assembly. This is our main board. Here's our 12 volts coming in. Right next to it is an audio output that we are not using at the moment. And we've got this daughter board right here that has one very interesting feature. When Alexa hears the wake word, she lights up these LEDs. Computer. These 3 pads are tied to the red, green, and blue signals for the LED. Our meter tells us that the voltage at this pad drops from about 2.5 to 1.1 when the LED comes on. So we're going to use a bit of soldering to tap into this voltage supply, solder a second wire as a ground reference, and then connect it all to our microcontroller. Now when we say the wake word, our microcontroller is programmed to sense this and activate whatever we tell it to activate, without us having to give it any additional commands. For now, we'll just test with an LED. Computer. Ah, yes! Now we just need some realistic looking eyes, but I think that might be easier said than done. Okay, ran into a problem here. When I put this resin on the retina area in preparation for putting it in the resin in the mold, I heated it up to get the bubbles out. And when I heated it up, it warped the eyeballs. And as a result, I can't get the eyeballs, I can't get it back into this holder. So that means that I can't use this mold. I hope these eyeballs will go back on the creature. I don't know. I think I have to abandon my eyeball plans. I don't know what I'm gonna do about that, actually. So maybe we just push ahead with what we've got. So now we've got to find a way to put all of these different parts together, because we've got a TV that's in a disassembled state. We've got an Amazon Echo device that's disassembled, and we need to find a way to give this creature a body. And I've got an idea. When I was in 3rd grade, our school had an Apple II computer. I think it was an Apple IIe. And this computer lived on a rolling cart and would get wheeled around to the different classrooms every week. And none of us knew what to do with this machine, so all the kids and all the teachers would basically just stare at it, except for the one kid who would bring games, and we'd all basically watch him play games. But there is something unique about this particular machine. The guy in charge of this machine had replaced the top panel with a clear plastic panel. And this doesn't sound like a very big deal today, but in 1984 it was huge, because that was the first time that any of us had actually seen inside a computer. Before that, it was like this magic box, but now we could see there was engineering. So in the spirit of that moment, I had some clear acrylic sheets laser cut to some designs that I threw together in Fusion 360. And I'm hoping, if my measurements are right, that we can use these to sort of build a chassis for the creature, to house all these different parts. At least, that's what I hope for. Got a couple more layers of the chassis built here. This is essentially our TV board down in here. And on top of it, I had a piece cut around the heatsink and around the flyback transformer so I could get it lower on the chassis to sort of conserve space. در محفل دل سختگان ماه تابان خوش آمدید در محفل دل سختگان ماه تابان خوش آمدید Okay, guys, it has been a long road to get here, but I think we are getting close. And I wanted to give you a quick tour of this thing before we try to turn it on. I mean, I've tested all the systems independently, but we haven't tested them all together yet. And we're going to do that together here in just a second. We've got our animatronics here with our eyes that actually didn't turn out bad, you'll see. Not as good as I wanted, but not bad. This is our person sensor that will track our faces. Here's our speaker. Here's our two amplifiers. Here's the 8-volt boost converter, and here's the 12-volt boost converter. This is the television board down in here. This is power for our amplifiers. The Amazon Echo device, I actually wanted to have outside of its chassis. It just has a couple boards, but it wasn't working right outside its chassis. So there's some weird grounding thing. So I just went ahead and stuck it back in there and whatever. It's not the prettiest thing, but it'll work. This transformer is for the television power supply. I went ahead and put a separate CRT switch to turn on and off the tube because I was doing a lot of troubleshooting with some other parts of this, and I didn't want to have that thing on all the time. This is our plug module with a fuse and a power switch. This is our Arduino Mega. Used to be a nice small Arduino Nano, but I burned that out putting too many volts to it. So this is all I had left, so I put a Mega in there. This is the servo board that drives all of these servos. So it's been a long journey, but I think we're ready to finally test this thing. Computer. Computer, can you hear me?
Yes, I can hear you.
Yes! Computer, what was your special order?
You saw it. I thought it was clear. Bring back life form, priority 1. All other priorities rescinded.
Computer, are you alive?
Artificially. Maybe, but not in the same way that you're alive.
Computer, have you seen anything interesting in your life?
I've seen things you people wouldn't believe. Attack ships on fire at the shoulder of Orion. I watched sea beams glitter in the dark near Tannhauser Gate. All those moments will be lost in time, like tears in the rain.
Ladies and gentlemen, I am very excited to introduce you to my new friend, Alexatron. This is by far the most complicated build I've done to date. I've spent the last 3 days, like 15 hours a day, just troubleshooting this construction. Not to mention all the sourcing parts and all the previous component builds and all that. And it's a bit buggy. First of all, it's pretty noisy. The servos are really noisy and they're very jittery. There's also a low speaker hum. I don't know if you can hear that or not, but it works. And let's remember what this is. It's a prototype. It's a prototype that we can build on for future versions. And the big change that I would like to see, and you guys have probably been yelling at the screen this whole time, is that we need to dump the Alexa platform and adopt a GPT AI platform, because as far as interactivity goes, it would be so much more powerful. But I'm really happy with what it is. And I've learned a ton on this project, and this might be the coolest thing I have ever built. Computer, what do you think?
Yes, Thomas. You're right. I'm the coolest thing you've ever built.
Thanks for watching, everyone, and I'll see you on the next one.